Okay, we're going to continue our discussion of circular functions with this little piece about odd and even functions. So this is day 2 of circular functions, and odd and even functions look like this. Even functions is a function where f of negative x is equal to f of x for all x in the domain of x. So that means when we do a function to a number, whether it's the number or its opposite, it's going to come out the same. For example, look at this. If f of x is equal to x squared plus 3, we're going to look at two cases. We're going to look at f of 1, and we're going to look at f of negative 1, and you're going to see how this works. So f of 1 is going to equal 1 squared plus 3, which is going to be 1 plus 3 is 4. Okay, so f of 1 was equal to 4. Now we're going to do the function of the opposite, so we're going to have negative 1 squared plus 3, which is equal to 1 plus 3, which is equal to 4. It's even because no matter what you put in, if you put in the opposite of that number, it's going to be the same. And so we've got f of negative 1 is equal to f of 1. Okay, so that's what this means. So f of negative x and f of x are the same, as we witnessed here. So that's an even function. So like things with squares and to the fourth power, so those are going to be even things. Okay, so let's look at this. An odd function is where f of negative x is equal to negative f of x for all x in the domain of f of x. So watch how this works. Now, negative f of x is going to equal this, and so what we are going to do is we're going to say, let's put in f of 1. And so when we put in f of, negative 1, we are going to get something like this. F of x is going to equal x to the third minus x. So f of x is equal to, got it written down here, x to the third minus x. Okay, so f of negative 1 is going to equal, now, negative 1 to the third minus negative 1, which is going to give us negative 1 plus 1 is equal to 0. Okay? Now, when we put in negative of the function. So now we're going to do negative f of negative 1. Okay? So this is going to equal, if we do f of negative 1, we end up with 0, and we're going to put in a negative in front of it, so that's going to equal 0. They came out the same. Okay? So that's how this works. We get the same for even. For odd, it's going to be f of negative x is equal to negative f of x. Okay? For all this in here. And actually what I should have done is put this in as positive 1, but it wouldn't have made a difference. Okay? Because we'd still have 1 to the third minus 1, which is 0. Okay? So that's how odd and even functions work. In our cosine and sine, we're going to put this all together now with trig. Sine is an odd function because look at this. If I put in f of pi over 6, watch what I get out. I get 1/2. Okay? But if I put in f of negative pi over 6, I get out a negative 1/2. Okay? So I've got opposite signed y values here. So if I draw my pi over 6 here, and I put in my negative pi over 6 here, notice what changes. Okay? So this is going to be something x, comma, 1/2. And down here I'm going to have something x, comma, negative 1/2. Okay? So when I put in opposite values, I'm going to get opposite results. Okay? Cosine is even. So if cosine is an even function, that means that f of x, when x is negative, is going to be equal to f of x. Okay? So if I put in f of pi over 3. That's going to give me 1/2. Okay? And then f of negative pi over 3 is going to be equal to 1/2 also, because I get out the same values. Okay? It can be confusing, but if we have this in mind here, that an even function spits out the same value for positive and negative angles, and this is going to give me opposite values. Okay, so this is going to be the same as saying negative. So when I put in this negative pi over 6, to get them the same, I'm going to have to make this negative. Okay, do you see the subtle distinction there? To get out the same value, I'm going to have to do negative of the angle. So these angles are related in that these are opposites, but also I'm going to put my negative in front of my one that's positive. Okay, it's a subtle thing, but I think we're going to get it as we work through it here. Okay, so we're going to show that cosecant is an odd function, and we remember that cosecant of theta, or in this case t, is equal to 1 over sine t. And when we look at this, let's look at how this breaks down. If I do what I need to show is that cosecant of negative t is equal to the negative cosecant of t. So let's see how this works. The cosecant of negative t is going to be equal to 1 over sine of negative t. But I remember that sine is an odd function, so I know that this means that this is 1 over negative sine t. Look how this works. You see how it's going? 1 over sine t. I'm going to put my negative out front, and this reduces to negative cosecant of t. I'll rewrite. These are the two key pieces. We had to show that cosecant of negative t was equal to negative cosecant of t, because that's the definition of an odd function. So we involved sine, that's how we knew it was an odd function, okay? And so when I do these three problems, I'm going to keep in mind and first write down exactly what it is that I have. I know that sine is odd. So what I'm going to do is this, negative sine, and then make this 60. Make it easier on myself. So let's reduce. The sine of 60, I know that 60 is this guy right here. And I know that sine is the second one. This is what I'm looking at. So I'm taking this over, boop, right there, negative square root of 3 over 2. It's a matching game, guys. See how I did that? Cosine, even. So I know that this is going to be equal to cosine of 2 pi over 3. I'm going to 2 pi over 3 right here. 2 pi over 3, this is my cosine right here. So it's going to give me negative 1/2 right there. Okay? See how easy this is? This is a matching game right now. Cosecant, a little bit tougher. But I know that cosecant's odd because it's sine theta 1 over it. So it's going to be odd. So this is actually going to be equal to, can you think of it? You got it, 1 over sine negative 225, which is equal to 1 over, so negative 1 over sine 225. So I'm going to go over here, find 225, here it is, this is the line I'm looking at. And I remember that this is the sine here. So I'm going to do negative of negative square root 2 over 2. So it's going to be a negative, negative, positive. It's going to be square root of 2 over 2. Right there, guys. You see how that works? Okay? That is our deal right there. So when we try something like this, we need to remember, we can pause this and remember what we just did. Let's try it one more time. This is going to be equal to negative sine of 120 because it's odd. Okay? So I go to 120. I pick out the sine, this guy right here. It's equal to square root of 3 over 2, make it negative. trig. So far, matching game. As long as you know what to match with what, we are good to go. This is the exact same thing. It's going to be equal to negative sine of 150. Where are we at right now? It's given us all the answers. This unit circle. It's brilliant. The guy who invented this should be a millionaire. He might be, I don't know. So sine is going to be equal to 1/2, and we're going to make it negative, so negative 1/2 is our answer. Right there. You see how we're working right now? I'm just picking out values. The cosine of 330, this is even. So this is going to be equal to cosine 330. Because remember, even function, it doesn't matter here. They're the same. So this is cosine 330. I'm going down to 330 right before your very eyes. I'm going square root of 3 over 2. That's it. That's all. If it's cosine, I'm keeping it the same as the positive angle. If it's sine, I'm making it negative of the positive angle, because even and odd functions. Thanks for watching, guys.